Welcome to my channel. Hey guys, welcome back to another episode. Today's topic is called What is Electronics? And in this episode, we will discuss what electronics is all about. So, by the end of this video, you'll know what electronics is and why you should learn about it. Also, we'll discuss the safety rules of electronics so that you don't get hurt while experimenting with electronics. Okay, without any further ado, let's get started. First, let's take a look at some of the animations related to the topic of electronics. Oh wow, this looks cool. A light bulb turning on, a robot moving, and a TV playing cartoons. All of this is done with the help of electronics. So let's find out more about it. Now, in simple terms, electronics is all about using electricity to make things work. For example, when you flip a switch and the light turns on, you are using electronics. When you press a button on your remote control and the TV changes channels, that's also electronics. When you turn on your computer or play with a toy, they all use electronics. So basically, electronics is everywhere. But do you know what electronics is in technical terms? Well, let me explain. Electronics is the branch of science that deals with the study of electric circuits and devices containing both electronic tubes and semiconductor devices. What the heck does that mean? Well, let's break it down. Electric circuits. These are the pathways that electricity flows through. Basically, a closed path through which electric current can flow. Now electric current, it's the flow of electric charge. It's like the water that flows through the pipes. Just like water flows through the pipes, the electric current flows through the electric circuits. Electricity, it's the energy that flows through the circuit, causing current to flow. And finally, semiconductor devices. These are the components that control and switch the flow of electricity, for example, transistors and integrated circuits. Wow, that was a lot of technical stuff. But don't worry, you don't need to be an expert in all of this to enjoy electronics. So let's move on to the next part of the video. Now let's discuss why you should learn about electronics. Learning about electronics can be super exciting. By learning about electronics, you can make your own inventions, such as an alarm system, a portable radio, a portable fan, a laptop power bank, and so much more, because you will learn how to combine different components to make them perform specific tasks. Pretty cool, right? Let's see what else you can do. With the help of electronics, you can build blinking lights, circuits that play music, self-balancing robots, and even robotic arms that can pick and place objects. And the best part is, you don't need to be a genius to learn electronics. Anyone with a bit of interest and patience can master it. With the help of electronics, you can build gadgets like this flashlight, this alarm system, a robotic arm, a portable fan, and so much more. Now, isn't that exciting? Isn't it fun to make your own gadgets? Just imagine showing off your inventions to your friends and wowing them with your knowledge of electronics. Plus, electronics is everywhere, so understanding how things work can make your life easier. You'll be able to fix broken devices, set up audio systems, and even program smart home devices. And who knows, maybe one day you'll invent something that makes life easier for everyone. That would be awesome, right? Well, before we move ahead in the world of electronics, there are a few things that you must keep in mind. Safety is the most important thing. If you want to have fun with electronics, you must follow these safety rules. Rule No. 1. Always use batteries to power your projects instead of plugging into the wall outlet. Batteries are low voltage, meaning that they won't cause much harm if you touch them accidentally. Wall outlets are high voltage and can be extremely dangerous. If you touch them, you can get a severe shock. So it's best to avoid them. Rule number 2. Keep your hands dry when working with electronics. Water and electronics don't mix well. If you have wet hands and touch an electric component, you can cause a short circuit. This can damage the component or even start a fire. So always make sure your hands are dry before working on any electronic project. Rule number 3. Never put metal objects like scissors, coins, or jewelry into a circuit. Metal objects can create a short circuit, damaging components and posing a risk of fire. Scissors, coins, and jewelry are all made of metal and should not be placed inside a circuit. Rule number 4. If anything feels hot, stop immediately and ask an adult for help. If you're working on an electronic project and something starts to feel hot, stop working on it right away and ask an adult for assistance. It is crucial not to continue working with hot electronic components as they could pose a risk of fire or serious injury. It's always better to be safe than sorry. Following these safety rules will ensure that you have fun and stay safe while exploring the world of electronics. Also, please remember that it is always a good idea to work with an adult nearby if you are trying something new or advanced with electronics. Alright, now that we've covered the basics of electronics and safety, let's look at what we're going to learn next. In the next episode of Basic Electronics for Kids, we will learn about electric circuits. We'll learn about the basic elements of an electric circuit such as a power source, wires, and a load. We'll also learn about the different types of circuits such as series and parallel circuits. So make sure to watch the next episode to learn more about electric circuits. Okay, we've come to the end of this episode, so let's quickly recap what we've learned. Electronics is all about using electricity to make things work. It's everywhere. We use electronics every day, from turning on lights to using computers. We can even use it to build our own inventions. And the best part, anyone can learn electronics. We also discussed some safety rules that we should follow while working with electronics. We learned that we should never plug into the wall socket, always use batteries to power our projects. We shouldn't touch electric components with wet hands, and we should never put metal objects into a circuit. Okay, that's all for today. Thank you for watching the first episode of Basic Electronics for Kids. If you liked this video, hit the like button below and subscribe to my channel so you don't miss any future videos. Also, share this video with your family and friends. Tell them what you learned about electronics. Once again, thank you for watching, and I'll see you in the next video. Bye-bye. We are building an electronic longboard, and this one does not require any glue or soldering, and it only takes 5 minutes to make. The best thing is that you can reuse the parts to make different circuits over and over again. What is awesome is that you can also add sensors and microcontrollers to make your circuits do amazing things. But let's start from the beginning. Let's build an electronic longboard from scratch. Hi guys, welcome to this channel where we learn about science, technology, engineering, and mathematics. Before we begin, remember to subscribe and hit the bell button so you never miss out on our new videos. In order to build circuits, we need 3 basic items: a power source such as a battery, components such as a light bulb or an LED, and a way to connect them together. For the simplest circuits, we can connect these components by wrapping the wires around each other or twisting them together. This works because the components have metal pins that make electrical contact with each other, but it's a bit inconvenient to make these connections all the time. Fortunately, we have tools called breadboards and jumper wires that make building circuits much easier. We will also need a multimeter to measure the voltage of the battery, and we'll show you how to use it later in the video. A breadboard is basically a blank canvas where you can freely place your components without worrying about burning or melting anything. It consists of many small holes that are all connected inside. All you have to do is stick some wires or components into the holes and they'll automatically connect. If you want to change the design, just pull them out and try again. There are a few rules to follow when placing components on a breadboard. First, don't put 2 components in the same row touching each other. They must be separated by at least 1 hole or an empty strip. Second, avoid putting the positive and negative terminals of a component in adjacent columns. Always leave a gap between them. And finally, keep in mind that the power supply and the components will heat up when the circuit is closed, so don't place them too close to each other. Try to keep at least 1 empty strip in between. These simple rules will help you prevent overheating and potential shorts in your circuits. Let's build a simple circuit that lights up an LED. An LED is a type of light bulb that uses a semiconductor to emit light when current passes through it. Semiconductors are materials that have an electrical conductivity between that of a conductor like copper and an insulator like rubber. The unique property of semiconductors is that they can control the flow of electricity under certain conditions. When you apply voltage across a semiconductor, electrons flow from one side to the other. As electrons pass through the semiconductor material, they recombine with positively charged holes. The energy released during the recombination process gets emitted as light. Red, green, blue, white, and other colors of LEDs are made from different semiconductor materials that emit different wavelengths of light. To build this circuit, we will need a power supply, a switch, an LED, and some wires. The power supply will provide the electrical energy to the circuit. The switch will allow us to turn the LED on and off. The LED will convert electrical energy into light, and the wires will connect everything together. First, plug the positive end of the battery into the positive terminal of the LED. Make sure that the arrow on the wire matches the stripe on the LED. The arrow indicates the direction of current flow. Next, plug the negative end of the battery into the negative terminal of the LED. Now let's close the circuit by connecting the other ends of the battery and LED together with a wire. Notice that I left a small gap between the positive and negative terminals of the battery. This is important because we don't want to short circuit the battery by connecting its positive and negative terminals directly. Short-circuiting a battery can damage the circuit and the battery. Now let's turn on the circuit and see if it works. If the LED doesn't light up, check your connections and try again. Once you get it working, experiment with turning the circuit on and off using the switch. You should see the LED light up every time you close the switch. Now let's take it to the next level and add a resistor to the circuit. A resistor is a component that limits the amount of current flowing through a circuit. It is measured in ohms, denoted by the Greek letter omega. The higher the resistance, the less current flows through the circuit. Resistors come in various values and sizes, but the most common ones are the ones with a color code on them. Each color represents a different value of resistance. For example, a resistor with a brown, black, red, and gold color code has a resistance of 10 ohms with a tolerance of plus or minus 5%. We will use a multimeter to measure the resistance of the resistor. A multimeter is a device that allows you to measure voltage, current, and resistance. It has three main functions. By turning the dial to volts, you can measure the voltage in volts V across a circuit. By turning the dial to amps, you can measure the current in amperes of flowing through a circuit. By turning the dial to ohms, you can measure the resistance in ohms of a component or a circuit. To measure the resistance of the resistor, turn the dial to ohms, insert the probes into the two ends of the resistor and read the value on the display. If the value is too high or too low, adjust the range using the dial selector button until you see a reading between 0.5 and 9.99. The multimeter we are using has an automatic ranging feature, which means you don't need to worry about selecting the right range manually. The multimeter will do it for you. To protect the LED from getting damaged, we need to add a current limiting resistor in series with it. The value of the resistor depends on the voltage of the LED and the current we want to flow through it. For this particular LED, the recommended current is 20 milliamps or 0.02 amps. Using Ohm's law, we can calculate the required resistance. Ohm's law states that the current flowing through a conductor between 2 points is inversely proportional to the resistance between those 2 points. Mathematically, it's expressed as I equals V divided by R, where I is the current, V is the voltage, and R is the resistance. Rearranging the formula to solve for R, we get R equals V divided by I. Plugging in the values, we get R equals 3 volts divided by 0.02 amps, which equals 150 ohms. Therefore, we need a resistor with a resistance of 150 ohms. Let's connect the resistor in series with the LED and see if it lights up. The circuit diagram shows the standard symbols used for the components. The battery is represented by a long rectangle with a plus sign. The LED is shown by a diode symbol with a triangle pointing towards the positive terminal of the LED. The resistor is shown by a zigzag line with a value number. The switch is represented by a circle with a line through it. The multimeter is shown by a symbol with a pointer. The wires are represented by straight lines connecting the components together. Congratulations! You just built a simple circuit that turns an LED on and off using a breadboard. You also learned how to measure the voltage, current, and resistance of a circuit using a multimeter. You saw how to connect an LED in series with a resistor and how to protect it from burning out. Now go ahead and experiment with different components and circuits. You can make a circuit that lights up multiple LEDs, a circuit that makes a motor spin, a circuit that plays a sound, and so on. Use your imagination and creativity to explore the world of electronics. If you enjoyed this video, give it a thumbs up. Subscribe to the channel and hit the bell button so you never miss out on our new videos. Thanks for watching and see you in the next one. Bye. Hello young engineers. Last time we built our very first circuit with a battery and a bulb. Today we'll meet 3 very important electronic parts: resistors, capacitors, and switches. Let's see what they do. First up, the The resistor. A resistor's job is to slow down electricity. Think of it like rocks in a river slowing down the water. Why is this useful? If too much electricity flows, a bulb or LED could burn out. Resistors protect them by controlling the flow. With no resistor, our LED is very bright, but with a resistor in the circuit, it's nice and safe. Resistors come in different values. These two are 100 ohms each. Put them together and you have 200 ohms. We can also put them in series with other parts like an LED. Then we need to subtract their values. If we want a total resistance of 100 ohms, this works great. If we want more resistance, we can add more resistors. These little boxes show the value of the resistance. This one has 4 numbers and 3 lines. The top number is the first line, the second number is the second line, etc., and that last tiny number tells us how many times we have to multiply the whole thing by 10. So this box means 700 ohms, but there's a shortcut. We can use this table to find out. Look for the color bands on the resistor and follow the columns across until you get a number. If the band is in between, pick the closest number. This resistor is red, orange, blue, and brown. Find those colors on the left side and then read across to get 20 ohms. This one is yellow, violet, red, and gold. Read across to get 40 ohms. And this one is green, red, orange, and silver. Read across to get 82 ohms. Pretty cool, huh? Resistors save LEDs from burning out. But how can we make our LEDs do something really cool? We'll find out in part 2. If you're having fun, hit that subscribe button so you don't miss out on future episodes. Next is the capacitor. A capacitor is like a tiny bucket. It can store electricity and release it later. Here's an example. In cameras, capacitors store energy to make the flash go off. When the camera takes a picture, it needs energy. Where does it get that energy? From the capacitor. The larger the capacitor, the more energy it can store. How do we measure how much energy a capacitor can store? Well, they're measured in farads. This one stores 100 microfarads of energy. That doesn't seem like much, but remember it's a tiny bucket. A typical electrolytic capacitor might store 1000 microfarads, but this still isn't enough to power a device on its own. Instead, capacitors work best when they help control and smooth out the flow of electricity. They're often used in pairs called a capacitor bank. You can even use them to make an LED blink by charging it up and then letting it discharge. To do this, let's build a circuit with a battery, a capacitor, a resistor, and an LED. The battery charges up the capacitor and the resistor controls how fast the capacitor discharges. After a little while, the capacitor will run out of charge and the LED will stop blinking. This is kind of like a switch that turns off after a while. How long the switch stays on is called the time constant and is usually calculated in seconds. If the time constant is small, the switch will stay on for a short time. If it's large, the switch will stay on longer. Want to play with this idea? Try changing the values of the resistor to make the LED blink faster or slower. Another fun trick is to use 2 capacitors in series. This way we can get a time constant up to around 3 minutes. That's about the length of a TV commercial break. So if you set this up before going to the bathroom, the LED should just barely finish blinking by the time you get back. But be careful because if you touch these metal pins, a lot of electricity will suddenly start flowing through your body. Yikes. I think I need a better design. And finally, the switch. A switch is like a gate. When it's open, the electricity can't pass. When it's closed, the electricity flows. This is how you turn your room light on and off every day. Try this demo with a battery and a bulb. Connect the battery to the switch. Nothing happens because the switch is open. But when you close the switch, the light turns on. In part 4, we'll have some fun putting all these parts together. But first let's see how they're made. Switches, capacitors, and resistors can be made in many different ways. Sometimes they're mechanically like this switch, which uses moving contacts to complete a circuit. Other switches are solid state, meaning they use semiconductors to turn on and off. They don't have any moving parts. Capacitors are also made in a variety of ways depending on their function. Some capacitors use 2 pieces of metal foil separated by a sheet of paper or plastic. Electrolytic capacitors use chemicals to increase the capacitance, and some capacitors look like little cylinders. These are called ceramic disc capacitors. Resistors can be made with various technologies too. Some of the simplest resistors use a resistive material like this carbon composition resistor. Others use a thin film deposited onto a substrate. No matter how they're made though, all resistors obey Ohm's law. The voltage drop across a resistor is equal to the current times the resistance. Switches, capacitors, and resistors are all passive components. They convert and control the flow of electricity, but they don't amplify it or add any power to the circuit. Active devices like transistors do require additional power. Now it's time for some fun. Here's a challenge. Try adding a switch to your simple circuit from last time. That way you can turn your light on and off just like a real lamp. Remember to leave space between the writing and the edge of the board. Then write out the steps for your circuit. Start with a battery. Then write down the other parts you use and connect them with wires. Finally, test your circuit to make sure it works. If it does, you're done. If not, go back and check your connections. Be careful not to leave any gaps in the wires. Now it's time for the quiz. First question. What is the purpose of a resistor? Is it to store electricity? Is it to control the flow of electricity? Or is it to protect your battery? A resistor slows down or resists the flow of electricity. So the answer is C. Resistors protect your battery by controlling the flow of electricity. Next question. What is a switch used for? Is it to light up? Is it to change the color? Or is it to control the flow of electricity? A switch controls the flow of electricity. So the answer is C. Great job. And final question. What does a capacitor look like? Is it a square, a circle, or maybe a lightning bolt? A capacitor looks like a bucket. So the answer is A. That's right. You got them all right. Good job. It's time for the experiment. Make a note of the date and today's experiments here. Write your observations on the left and any ideas you have on the right. Here's a table with the parts we used today. It's time to explore the world of electronics. There are many interesting parts, and today we learned about 3 important ones: resistors, capacitors, and switches. They are the building blocks of circuits, and we can use them to build all sorts of amazing things. But how do we choose which one to use? Well, that's for you to find out in our next episode, where we'll learn about diodes, LEDs, and transistors, the real superheroes of electronics. See you then. Hello, young engineers. Last time we built our very first circuit with a battery and a bulb. Today we'll meet 3 very important electronic parts: resistors, capacitors, and switches. Let's see what they do. First up, the resistor. A resistor's job is to slow down electricity. Think of it like rocks in a river slowing down the water. Why is this useful? If too much electricity flows, a bulb or LED could burn out. Resistors protect them by controlling the flow. With no resistor, our LED is very bright, but with a resistor in the circuit, it's nice and safe. Resistors come in different values. These 2 are 100 ohms each. Put them together and you have 200 ohms. We can also put them in series with other parts like an LED. Then we need to subtract their values. If we want a total resistance of 100 ohms, this works great. If we want more resistance, we can add more resistors. These little boxes show the value of the resistance. This one has 4 numbers and 3 lines. The top number is the first line, the second number is the second line, etc., and that last tiny number tells us how many times we have to multiply the whole thing by 10. So this box means 700 ohms. But there's a shortcut. We can use this table to find out. Look for the color bands on the resistor and follow the columns across until you get a number. If the band is in between, pick the closest number. This resistor is red, orange, blue, and brown. Find those colors on the left side and then read across to get 20 ohms. This one is yellow, violet, red, and gold. Read across to get 40 ohms. And this one is green, red, orange, and silver. Read across to get 82 ohms. Pretty cool, huh? Resistors save LEDs from burning out. But how can we make our LEDs do something really cool? We'll find out in part 2. If you're having fun, hit that subscribe button so you don't miss out on future episodes. Next is the capacitor. A capacitor is like a tiny bucket. It can store electricity and release it later. Here's an example. In cameras, capacitors store energy to make the flash go off. When the camera takes a picture, it needs energy. Where does it get that energy? From the capacitor. The larger the capacitor, the more energy it can store. How do we measure how much energy a capacitor can store? Well, they're measured in farads. This one stores 100 microfarads of energy. That doesn't seem like much, but remember, it's a tiny bucket. A typical electrolytic capacitor might store 1,000 microfarads, but this still isn't enough to power a device on its own. Instead, Capacitors work best when they help control and smooth out the flow of electricity. They're often used in pairs called a capacitor bank. You can even use them to make an LED blink by charging it up and then letting it discharge. To do this, let's build a circuit with a battery, a capacitor, a resistor, and an LED. The battery charges up the capacitor and the resistor controls how fast the capacitor discharges. After a little while, the capacitor will run out of charge and the LED will stop blinking. This is kind of like a switch that turns off after a while. How long the switch stays on is called the time constant and is usually calculated in seconds. If the time constant is small, the switch will stay on for a short time. If it's large, the switch will stay on longer. Want to play with this idea? Try changing the values of the resistor to make the LED blink faster or slower. Another fun trick is to use two capacitors in series. This way we can get a time constant up to around 3 minutes. That's about the length of a TV commercial break. So if you set this up before going to the bathroom, the LED should just barely finish blinking by the time you get back. But be careful because if you touch these metal pins, a lot of electricity will suddenly start flowing through your body. Yikes. I think I need a better design. And finally, the switch. A switch is like a gate. When it's open, the electricity can't pass. When it's closed, the electricity flows. This is how you turn your room light on and off every day. Try this demo with a battery and a bulb. Connect the battery to the switch. Nothing happens because the switch is open. But when you close the switch, the light turns on. In part 4, we'll have some fun putting all these parts together. But first, let's see how they're made. Switches, capacitors, and resistors can be made in many different ways. Sometimes they're mechanically like this switch, which uses moving contacts to complete a circuit. Other switches are solid state, meaning they use semiconductors to turn on and off. They don't have any moving parts. Capacitors are also made in a variety of ways depending on their function. Some capacitors use two pieces of metal foil separated by a sheet of paper or plastic. Electrolytic capacitors use chemicals to increase the capacitance, and some capacitors look like little cylinders. These are called ceramic disc capacitors. Resistors can be made with various technologies too. Some of the simplest resistors use a resistive material like this carbon composition resistor. Others use a thin film deposited onto a substrate. No matter how they're made though, all resistors obey Ohm's law. The voltage drop across a resistor is equal to the current times the resistance. Switches, capacitors, and resistors are all passive components. They convert and control the flow of electricity, but they don't amplify it or add any power to the circuit. Active devices like transistors do require additional power. Now it's time for some fun. Here's a challenge. Try adding a switch to your simple circuit from last time. That way you can turn your light on and off just like a real lamp. Remember to leave space between the writing and the edge of the board. Then write out the steps for your circuit. Start with a battery. Then write down the other parts you use and connect them with wires. Finally, test your circuit to make sure it works. If it does, you're done. If not, go back and check your connections. Be careful not to leave any gaps in the wires. Now it's time for the quiz. First question. What is the purpose of a resistor? Is it to store electricity? Is it to control the flow of electricity? Or is it to protect your battery? A resistor slows down or resists the flow of electricity. So the answer is C. Resistors protect your battery by controlling the flow of electricity. Next question. What is a switch used for? Is it to light up? Is it to change the color? Or is it to control the flow of electricity? A switch controls the flow of electricity. So the answer is C. Great job. And final question. What does a capacitor look like? Is it a square, a circle, or maybe a lightning bolt? A capacitor looks like a bucket. So the answer is A. That's right. You got them all right. Good job. It's time for the experiment. Make a note of the date and today's experiments here. Write your observations on the left and any ideas you have on the right. Here's a table with the parts we used today. It's time to explore the world of electronics. There are many interesting parts, and today we learned about 3 important ones: resistors, capacitors, and switches. They are the building blocks of circuits, and we can use them to build all sorts of amazing things. But how do we choose which one to use? Well, that's for you to find out in our next episode, where we'll learn about diodes, LEDs, and transistors, the real superheroes of electronics. See you then. Hello again, young inventors. Welcome back to another exciting episode. And today, we're going to learn about the basic principles of electricity. We'll cover topics such as current, voltage, and resistance. Now, before we dive into this exciting topic, let's quickly review some of the items in my electronics kit. As shown previously, here is a list of items that you will need to complete some of the experiments in this video. You can find links to all these items in the description below. Alright, so let's have a quick recap from episode 1. We learned that electronics is all about controlling the flow of electricity. To prevent getting hurt by electricity, we need to follow 3 simple rules. Rule number 1. Never touch bare wires while electricity is turned on. Rule number 2. Keep your hands and metal objects away from electrical outlets. And rule number 3. Always unplug electronics when you are not using them. Now that we know how to be safe when working with electricity, we are ready to learn the 3 superstars of electricity. These are current, voltage, and resistance. So let's meet these guys and learn about their superpowers. So what is electricity? Well, it is an invisible force that we cannot see, but we know that it exists because we can see its effects. For example, when we turn on the lights in a room, the room becomes brighter. Electricity is similar to water flowing through a pipe. We cannot see the water, but we can see the effects of the water. For example, when water flows through a sprinkler, we can see the grass getting wet. So the first superstar of electricity is called current. Current is the flow of electricity. Just like water flowing in a river, current is the flow of electricity. More current means a stronger flow of electricity. Less current means a weaker flow of electricity. So current is measured to find out how strong or weak the flow of electricity is. The unit for measuring electric current is called the ampere, represented by the letter I, in honor of André-Marie Ampère, who was a French mathematician and physicist. Current is represented by a capital I or sometimes lowercase I in a circuit. Current flows from the positive side of the power source, such as a battery, to the negative side of the power source. The second superstar of electricity is voltage. Voltage is the push that makes electricity move through a circuit. Think of a water tower pushing water through a pipe. Higher voltage means a higher push and a lower voltage means a lower push. Voltage is also known as electrical pressure or electrical potential difference. Voltage is measured in volts, symbolized by the letter V in honor of the Italian physicist Alessandro Volta. In a circuit, voltage is represented by a capital V or sometimes lowercase v. Voltage is always higher at the positive terminal than at the negative terminal of a battery. For example, if we measure the voltage of a battery and get a value of 9 volts, then the positive terminal of the battery has 9 volts while the negative terminal of the battery has 0 volts. The third superstar of electricity is resistance. Resistance is what slows down or stops the flow of electricity. Just like rocks in a river slow down the flow of water, resistors in a circuit slow down the flow of electricity. If there is no resistance in a circuit, then all the electricity would flow out of the negative terminal of the battery and nothing would work. Resistance is measured in ohms, symbolized by the Greek letter omega, in honor of the Greek scientist Georg Simon Ohm. In a circuit, resistance is represented by a capital R or sometimes lowercase r. These 3 superstars work together to make our electronic devices work. Now that we know about these 3 superstars, let's see how they work together using a simple circuit. This is a simple circuit diagram. A circuit is a path that electricity follows to deliver power. This circuit has 2 components, a battery and a light bulb. The battery provides the voltage and the light bulb provides the resistance. When we turn on the switch, a circuit is formed. The electricity flows from the positive side of the battery through the switch and then through the light bulb, completing the circuit. The electricity then returns to the negative side of the battery. The flow of electricity through the circuit causes the light bulb to glow. Once we remove the light bulb from the circuit is broken. Therefore, the light bulb will stop glowing. Scientists discovered something amazing about these 3 superstars. They found that if they multiply the current by the resistance, they get the voltage. Mathematicians wrote this relationship as an equation called Ohm's law. So V stands for voltage, I stands for current, and R stands for resistance. Now don't worry if it seems hard to understand. It's actually very easy. Let's break it down. V is equal to I times R. V is the voltage in a circuit. I is the current flowing through the circuit and R is the resistance in the circuit. This equation tells us how much voltage is needed to make a certain amount of current flow through a certain amount of resistance. For example, if we use a 9-volt battery and measure a current of 2 amps flowing through a resistor, then we can calculate the resistance using Ohm's law. Now let's try a quick quiz. What do you think will happen if we increase the voltage? Well, according to Ohm's law, increasing the voltage will cause the current to increase, assuming the resistance remains constant. Likewise, if we increase the resistance, the current will decrease. Let's perform a quick demo to show how these superstars work together. Here is a battery connected to a wire with a bulb in series. When we connect the circuit, the bulb lights up. Why does the bulb light up? Well, the battery provides the voltage that pushes the current through the wire and the bulb. The resistance in the bulb causes the current to slow down, which generates heat and light. Now that we know how a simple circuit works, we are ready to learn about series and parallel circuits. In a series circuit, all components are connected end to end along a single path. In a parallel circuit, all components are connected across the same points, meaning that all components are on the same path. Series circuits are simple, but if one component fails, then the entire circuit fails. Parallel circuits are more complex, but if one component fails, the other components continue to work. Now that you know the basics of electricity, you are ready to build your very first circuit. In our next episode, we will build a circuit with a battery and a light bulb. Make sure to check out the next episode where we will continue our exciting journey. Don't forget to like, subscribe, and share with your friends. Thanks for watching. Hey, little engineers, welcome back. Last time you learned about resistors, capacitors, and switches. Today, we're going to meet 3 more super cool components: diodes, LEDs, and transistors. Let's dive right in. First up, the diode. Have you ever been stuck in traffic? You're in a car on a one-way street. Cars are zooming by in one direction only because that's the direction the street was built for. They can't go the other way because there are no lanes and there is a big wall blocking their path. Well, a diode is just like this one-way street for electricity. Electricity has a flow to it like water running through a hose or current flowing through a river. And just like our one-way street, electricity will only flow in one direction through a diode. But why is this helpful? Well, sometimes you want to make sure that electricity goes in only one direction. In a circuit, there might be parts that could get damaged if the electricity goes the wrong way. So you use a diode to protect them. It's like having a security guard to keep everything safe. Let's take a look at this circuit here. If I put my battery in the circuit, electricity flows from the positive end to the negative end through the wire and then through the light bulb, making it shine nice and bright. Now let's add a diode to the circuit. I wonder what will happen. You've got the right idea. But try again. Wait. Why won't it work? That's right. Electricity won't flow through the diode the way you tried. Remember, a diode is a one-way street for electricity. The electricity can only go one direction through it. You have to turn your battery around so that the positive end touches the long leg of the diode and the negative end touches the short leg. Now watch what happens. It's amazing. The light bulb turns on. When the electricity flows in the right direction through the diode, it's like the cars can zoom through our one-way street no problem. But if I reverse the battery, nothing will happen. The light bulb won't turn on because electricity can't flow the wrong way through the diode. It's like trying to drive the wrong way on a one-way street. It just doesn't work. So when you're using a diode in a circuit, always remember, they only allow electricity to flow in one direction. Next up, let's talk about the LED. Hey, did you know that LED stands for light emitting diode? An LED is a special kind of diode that glows when electricity passes through it. Did you see that? The LED started glowing right away. So what's happening here? Well, when the electricity flows through the LED in the right direction, it lights up. But if we reverse the battery, nothing happens. That's because the LED is a diode. And remember, electricity can only flow in one direction through a diode. This means that the LED will only light up if the electricity goes in the right direction. Now let's look at these 2 LEDs. I'm going to connect them both to the same battery and switch, but I'll connect each LED with a resistor. That's important. We'll talk about resistors in a bit. Now watch what happens when I flip the switch. Wow, both LEDs are glowing. Cool. We can even connect many LEDs to the same circuit. Look at this. All these LEDs are connected together, and they all light up when the electricity flows in the right direction. LEDs are super useful. They're used in toys and TV remotes, traffic lights and computer screens, and pretty much anywhere you need a little light. They're energy efficient and come in all different colors. Maybe someday you'll invent something cool that uses LEDs. Now, let's explore the mighty transistor. Transistors are super tiny electronic switches that can automatically turn other things on and off, or make weak electricity signals much stronger. They look small, but they're really powerful. Transistors have 3 legs or pins that connect them to the rest of the circuit. But what makes them so great? Well, let's find out. Here's a transistor connected to a battery and an LED. Wait, why isn't the LED turning on? Well, let's try putting a small amount of electricity into the transistor's base pin. I'll use this little battery to do it. When I flip the switch on the small battery, watch what happens. Isn't that amazing? The LED turns on when I put just a small amount of electricity into the base pin of the transistor. And if I put more electricity in the transistor, the LED gets brighter. And when I turn the electricity off, the LED goes dark again. This is because the transistor is like a tiny electronic switch. When there's a small amount of electricity in the base pin, it turns on and electricity can flow from the collector pin to the emitter pin through the LED, making it glow. But if there's no electricity in the base pin, the transistor is off and the electricity cannot flow through the LED. Transistors are super helpful because they can automatically turn things on and off. For example, when you play a song on your phone, the volume changes as you slide the thing on the screen. Transistors are used to make that happen. They can also make weak signals stronger. Your phone's antenna receives signals from faraway towers. These signals are weak, but transistors can strengthen them so your phone can still work well. Transistors are truly amazing. They help us do all kinds of things, like store electricity as charges, amplify weak signals, and control robots and motors. They're also used in solar cells and wind turbines to generate clean energy. So next time you see an electronic device, think about all the tiny transistors inside working hard to make it happen. Now it's time for some fun. Can you build a simple circuit with an LED? You'll need a battery, a resistor, and an LED. Connect the positive side of the battery to one side of the resistor and the negative side of the battery to the other side of the resistor. Then connect the longer leg of the LED to the positive side of the battery and the shorter leg of the LED to the negative side of the battery. Remember, don't forget the resistor or else the LED might burn out. If you need some help, check out this video. Now go ahead, try it out. See if you can make your LED glow. In our next episode, we'll explore the tools young engineers use, like the breadboard and multimeter. See you there. And remember, keep on thinking like an engineer. Hey, little engineers, I hope you enjoyed this video. If you want to keep learning about engineering, subscribe for more fun science and engineering adventures. And check out our other videos where kids learn about topics from civil engineering to computer science and everything in between. Thanks for watching and I'll see you next time. In the last episode, we made a super cool alarm system with a buzzer, an Arduino, and a switch. Today, we're building something awesome with 3 LEDs. Have you guessed what this circuit is yet? It is a traffic light circuit. I love this one because we get to see some basic timing principles in action. And also, kids can learn about traffic rules while playing with this. So let's start building. Before we start building the traffic light circuit, we should probably answer the question, what actually is a traffic light circuit? Well, as the name suggests, this circuit uses 3 LEDs, typically red, yellow, and green. These LEDs will turn on and off in a particular sequence. And that's exactly how the traffic lights work. When you are driving your car on the roads, the traffic lights will turn red, then yellow, and then green, and the cycle keeps repeating over and over again. Now, in our circuit, we will build a similar mechanism. We'll turn on the first LED, wait for some time, and then we'll turn it off and move on to the next LED. This entire process will keep repeating forever, just like the real traffic lights. Now that we know what we're building, let's take a look at the materials that you will need. For this traffic light circuit, you will need 3 LEDs. One LED can be green, another can be yellow, and the third one can be red. Or you could use any combination of colors. However, if you are using different colors other than the traditional red, yellow, and green, make sure that your breadboard and the battery is connected properly. Otherwise, the circuit won't work correctly. Next, you will need 3 resistors. Resistors limit the amount of current flow in the circuit and they protect the LEDs from burning out. Since we are connecting 3 LEDs in series, we only need 1 resistor for each LED. Lastly, you will also need a breadboard and some wires to connect everything together. However, I will show you later how to connect these components properly. But before we start building this traffic light circuit, make sure that you have watched the previous episodes. You can watch them right here. Once you have everything ready, let's start building our traffic light circuit. Now, building this traffic light circuit is extremely easy. In fact, I think most of you will be able to complete this circuit by yourselves. However, if you're new to circuits, don't worry, because I'll explain every step in detail. So let's start. First step, grab your breadboard and place the LEDs on the breadboard. You can place the LEDs in any order because we'll be connecting the LEDs one after the other. That means the first LED that you placed on the breadboard will be your first LED and the last one will be your third LED. Once you're done placing the LEDs, now grab your resistors and place them one by one next to the positive leg of the LEDs. Make sure you place one resistor per LED. Now let's look at how we should connect the circuit. Now since we're using a 9-volt battery, we'll be connecting the battery in series with all these LEDs and resistors. So first, take the positive side of the battery and connect it to the first resistor. After that, connect the output side of the first resistor to the positive side of the second LED. Now take the positive side of the second LED and connect it to the second resistor. Now connect the positive side of the third LED to the negative side of the second resistor. Now connect the negative side of the first LED to the negative terminal of the battery. Make sure that you have connected everything correctly. Otherwise, the circuit won't work properly. Now this is an open circuit, which means if you connect the circuit right now, none of the LEDs will turn on. So now let's close the circuit. As soon as you do that, you should see all the LEDs glowing brightly. Congratulations! You have just built a traffic light circuit. Isn't this so cool? Try turning on and off the circuit. It's so much fun. Now we built a really nice traffic light circuit, but there's a small problem with this circuit. None of the LEDs turn off. They're all glowing at the same time, and that's not how the real traffic light works. In the real world scenario, one LED should glow at a time. Either the green LED should glow or the red LED, but not both of them at the same time. However, fixing this problem is really easy. All you need is a transistor or a small microcontroller circuit, and then we can turn the LEDs on and off automatically. Now I explained this in detail in my previous videos, so I suggest that you watch those videos to learn more about microcontrollers. Once you have learned the basics, you can come back and finish this traffic light project. And if you're wondering how to control the timing of these LEDs, you can check out this video. Now that you have completed this traffic light circuit, try answering the following questions. Write down your answers in the comments section below. Question number 1, which is the positive terminal of the battery connected to the first LED? Question number 2, which is the negative terminal of the battery connected to? And question number 3, which component protects the LEDs from burning out? Now that you have answered all the questions, let me reveal the correct answers. Answer number 1. The positive terminal of the battery is connected to the first resistor. Answer number 2. The negative terminal of the battery is connected to the first LED. And answer number 3. The resistors protect the LEDs from burning out. By the way, if you enjoyed answering these questions, make sure to try out the quiz at the end of this video. So far we learned how to build a traffic light circuit, but this circuit has some limitations. The biggest limitation is that all the LEDs turn on at the same time. That's not how the real traffic light works. However, we can easily fix this issue by adding some extra hardware to the circuit. Also, I explained all these concepts in detail in my earlier videos, so I suggest you watch them if you want to learn more. If you think you know enough about electronics to solve this traffic light problem, I would highly encourage you to try solving this challenge without watching my videos. It's a great way to test your skills, so go ahead and try it out. Now let's talk about the most exciting part of this challenge. There are 3 LEDs in the circuit, which means there are 6 possible combinations. Let's say the first LED is red, then the second can be either yellow or green, and the third LED can also be either yellow or green. That gives us 6 unique combinations, and you can randomly select any one of these combinations. Then you have to make a circuit where the selected LEDs blink one at a time. This will give you a beautiful traffic light effect. However, there are many ways to complete this challenge, and the best thing is that this is a very engaging way to learn about electronics. Now, once you have completed the challenge, share your ideas with others in the comment section below. Who knows, maybe you can help someone else understand this concept better. Today, we learned how to build a simple traffic light circuit, We also saw how we can make some modifications to this circuit to make it more interesting. The traffic light circuit is a great introduction to the wonderful world of electronics. Kids can learn a lot about timing by playing with this circuit. Moreover, it's also a lot of fun to play with this circuit. That was it for today's episode. In the next episode, we'll learn how electronics are used in our daily lives. We'll also do a fun project using switches and LEDs. So make sure to stay tuned. I'll see you guys in the next episode. Bye. Bye. Hey guys, thanks for watching. If you want to learn more about electronics, there are some fantastic courses online. The best part is that these courses are super interactive and fun. So go ahead, check them out. Thanks for watching. I'll see you guys in the next video. Bye. Bye. I'm building circuits because I like making things with my hands. I think that's what brought me to engineering. When I started to learn about circuits, I was really interested in being able to use my hands to control things around me, to interact with them. And the projects we are doing are similar to some of the very basic foundational projects that someone starting out in engineering might do to learn about the basics of how electricity works. So these are great projects for kids. They're also great if you want to brush up on your own knowledge of electronics. In episode 7, we learned how to make an LED light up. And last time, we turned that into a flashing LED circuit by adding a capacitor and a resistor. Today, we're gonna make something that makes sound, a simple buzzer alarm. We are gonna make a circuit that uses a buzzer and a 9-volt battery, and then we are gonna see how we can make that buzzer go on and off by connecting a switch into our circuit. So let's get buzzing. Alright, so what is a buzzer? Well, a buzzer is a device that produces sound when electricity flows through it. Now they're used in all kinds of different places. For example, buzzers are used in toys. They're used in alarms. Even things like microwaves, they have a buzzer to get your attention. And today we're going to be making our very own buzzer. So the first thing I am going to do now is show you kind of the finished product, and then we are going to walk through each of the steps. So if I turn the power on, you'll hear that buzz, and if I turn the power off, you'll hear that buzz. So that's exactly how a buzzer works. Alright, so that's what we're going to be working towards. Now let's take a look at the components that we need. First off, we obviously need a buzzer. This is our buzzer. Next, we need a battery. Batteries are the power source for our circuit. They're going to supply the electricity that will flow through our circuit and make our buzzer go. In this particular case, we're going to be using a 9-volt battery. But if you don't have a 9-volt battery, you could use 2 double-A batteries and an adapter. We'll put the link for that in the description below. Next, we're going to need a resistor. A resistor limits or restricts the amount of electricity that goes through our circuit. If we didn't have a resistor, we would risk burning up our buzzer. So we definitely need a resistor for this project. Now this project requires a special 220 ohm resistor. I've put links in the description below for where you can find that exact resistor. And finally, we're going to need wires and clips or a breadboard. I love using breadboards for projects like this because it makes it really easy to snap components together without having to strip any wires or anything like that. But if you have clips, you can use that too. So whatever you have, feel free to use what you have. Alright, so now we know the parts that we need. Let's take a look at how it works. So our electricity is going to come out of the positive side of the battery. It is going to travel through our resistor, and then it is going to go through our buzzer, and then it is going to complete the circuit by going back to the negative side of the battery. So if you're getting a little bit confused, don't worry. We are going to break it down step by step, and we are going to start with step number 1. Step number 1 is to grab the positive wire, grab the positive end of the battery, and grab the positive terminal of the buzzer, and we are going to attach those 3 together. Now, it is really important here to pay attention to which components are positive and which components are negative. If you accidentally connect something to the wrong component, you could burn up your components, or even worse, you could hurt yourself. So always pay attention to which ones are positive and which ones are negative. Alright, so that's step number 1. Step number 2, we're going to take our negative wire. We are going to attach it to the negative terminal of the buzzer, and then we are going to attach it to the negative end of the battery. Okay, so before we move on to step 3, I just want to take a second to point out that if you're using a breadboard, you'll notice that this red line connects to columns on the breadboard. This is because you can connect electricity sideways on a breadboard as well as forward and backwards. So that's why we're connecting it that way. But if you're using alligator clips, you'll just connect it straight like this. Alright, so step 3. We are just going to take our buzzer and we are just going to make sure that it is nice and snug. Make sure it's connected properly and that completes our circuit. So if I turn my power on right now, nothing should happen. So this is kind of like the setup phase where we're getting everything ready to go. And then once we turn the power on, we should hear our buzzer go off. So let's go ahead and give it a try. I'm gonna turn the power on and there you go. Wasn't that easy? You just built your very own buzzer alarm. Pretty cool, right? So now that we've built our buzzer alarm, we're going to make it a little bit smarter. We are going to add a switch into our circuit so that we can turn our buzzer on and off. So right now if I turn the power on, you can hear that my buzzer is going off. But if I wanted to turn it off, what I could do is unplug it from the battery. But that's a little bit annoying, right? I mean, I'd rather have a switch where I can just turn it on and off like this. So let's go ahead and add that into our circuit. So we're going to add the switch into our circuit right after the resistor. So we're going to grab our switch. We are going to connect the positive side to where the buzzer connects to the battery, and we are going to connect the negative side of the switch to the resistor. So basically, what this is doing is it's creating a pathway between the battery and the buzzer, and then when we flip the switch open, it breaks that pathway and turns the buzzer off. Now, if I flip the switch closed again, you'll hear that buzz. So it's creating a complete circuit. So if I flip it open, no circuit, no buzz. Flip it closed, complete circuit, we hear the buzz. So hopefully you guys had a lot of fun with this project. Building circuits is such a great way to understand how things work. It's also a really fun activity to do with kids. And this project in particular is great because not only is it fun, but it's also educational. Like it teaches kids about electricity and how things work, but it's also fun. I think that's the best kind of project, something that's both fun and educational. If you enjoyed this project, please consider giving us a thumbs up. We really appreciate the support. Also remember that this is the second video in our Electronics Basics series. If you missed the first one, go ahead and check it out. We made an LED flashing circuit. Next time we're going to make a traffic light circuit. And if you're excited about that, go ahead and hit subscribe so that you don't miss out on future updates. Thanks so much for watching. We hope you enjoyed the video, and we hope you learned something new. Remember, it's okay to make mistakes. Mistakes are just another excuse to learn and improve. So don't be afraid to make mistakes. Learn from them and keep trying. Thanks for watching. Hey there, welcome back to another exciting episode of Little Inventors, where kids learn about electronics while having fun. If you're new here, be sure to subscribe so you never miss an episode. Also, don't forget to leave us a comment down below to let us know what you think of today's project. And if you liked this video, remember to give it a big thumbs up. In the last episode, we talked about watts and how to calculate them. We also learned how to choose the right size for resistors based on the amount of current that needs to go through them. Today, we are going to put our newly acquired knowledge to good use and build a circuit that actually does something interesting. But before we jump into it, I have a question for you. Have you ever wondered what the heck a flashing LED is? This is a normal LED. This is a flashing LED. Can you spot the difference? Of course you can. One is flashing while the other one isn't. Now you might think that flashing LEDs are just magical electronic components, but they're actually not. A flashing LED is nothing more than a normal LED that has been hooked up to a special circuit that makes it blink. And guess what? You can make this circuit yourself. Stay with me and I'll show you how. All you need to make a flashing LED circuit is one LED, one resistor, one capacitor, and one transistor. All these components work together to make the LED flash. But how? Well, don't worry. I'm gonna explain that next. For now, let's take a look at the parts again. This is the LED, this is the resistor, the capacitor, and the transistor. To hold all of these parts together, we're going to use a breadboard. A breadboard is essentially a blank canvas where you can connect all these electronic components together without having to solder anything. You might wonder, why do we need all these different components to make the LED flash? Why don't we just hook up the LED directly to the battery? Well, a normal LED doesn't do anything interesting. It just sits there and waits for someone to turn it on. That someone could be you, of course, if you hit the power button. Or maybe a switch would be better. Yeah, a switch sounds like a good idea. But if we connect the switch to the positive side of the LED, then when the switch is open, the LED won't turn on, which is exactly what we want. But what happens when the switch is closed? Exactly. The LED turns on. But wouldn't it be nice if it did something more interesting? Like turning on and off by itself. To do that, we're going to add a third wire. Instead of connecting the switch to the positive side of the LED, we're going to connect it to the negative side. Now when the switch is closed, the LED is still on. But what happens when we open it? Voila! The LED turns off. Cool. But how do we get the LED to blink? Well, by adding a few more components to the circuit, we can get the LED to turn on and off without even touching the switch. All we need is a bit of creativity. Let's start by adding a capacitor to the circuit. We are going to connect the longer leg of the capacitor to the negative side of the LED and the shorter leg to the ground rail. Then let's add a resistor. We are going to connect one end of the resistor to the positive side of the LED and the other end to a pin on the breadboard. Lastly, let's add the transistor. We're going to connect the first leg of the transistor to the positive rail, the second leg to the pin where we connected the resistor, and the third leg to the ground rail. Now, you might be wondering, why did we add a resistor? Well, the resistor protects the LED from getting too much electricity and burning out. Next, you may be wondering, why did we add a capacitor? The capacitor stores electrical energy while the circuit is turned on and slowly releases it while the circuit is turned off. You may also be wondering what the transistor is doing in this circuit. The transistor basically acts like a switch that turns on and off depending on whether there is enough electricity flowing through it. If there is, then it's on. If there isn't, then it's off. With all these components hooked up, we're ready to turn on the circuit. But before we do that, I have a question for you. Do you think the LED is going to blink? Leave a comment down below to let me know what you think. And now it's time for the moment of truth. Let's plug in the battery and voila. Isn't that amazing? The LED is blinking just like a tiny heartbeat. How cool is that? By connecting all these components together, we created a circuit that makes the LED light up and turn off by itself. That's what a flashing LED is. So why don't you try experimenting with this circuit some more? Try changing the resistor or capacitor. What do you notice about the blinking speed? Does the LED blink faster or slower? Try increasing or decreasing the size of the resistor. How does that affect the blinking speed? Experimenting with circuits like this is how you become a true electronics wizard. While experimenting, it's important to keep in mind the size of the resistor and capacitor. Why? Well, if we use a small resistor with a flashing LED circuit, the resistor will burn out. If we use a large resistor, the LED won't blink fast enough. The same goes for the capacitor. If we use a large capacitor, the LED won't blink fast enough. And if we use a small capacitor, the LED will blink so fast that we won't even notice it. So it is important to find the right balance between the size of the resistor and capacitor to get the desired blinking speed. Once you're done experimenting with the original circuit, why don't you try building a few more? You could make a circuit that uses a larger LED like this one. Or you could make a circuit that uses a smaller LED like this one. Or how about a circuit that uses 2 LEDs instead of 1? Ooh. Or maybe even 3 LEDs. Wow, the possibilities are endless. I've shown you how to make a basic flashing LED circuit. Now it's your turn to experiment and have fun. Blinking LEDs are used everywhere from toys to Christmas lights to smartphones. They're a great way to make electronics more fun and interesting. And if you want to take your electronics knowledge to the next level, then I have some great news for you. Just like you, I love building circuits and playing around with electronics. And that is why I have created a special website where you can learn all about electronics while having fun. On my website, you can play fun games, watch interesting videos, and even order electronics kits to build at home. Everything is designed to help you learn about electronics in a fun and engaging way. So if you want to learn more about electronics, then head over to my website and sign up for free. I promise you won't regret it. And that brings us to the end of today's episode. I hope you enjoyed learning how to make a flashing LED. In our next episode, we're going to build a simple buzzer alarm. Don't miss it. Before we go, I have a question for you. What do you think was the most interesting part of today's project? Let me know in the comments below. That's it for today. I hope you had fun and learned something new. Remember, if you enjoyed this video, hit that like button and subscribe for more fun learning adventures. Thanks for watching and I'll see you next time. batteries and simple circuits. Hello, friends. Welcome to this channel. We've got lots of exciting topics to cover today, so let's get started. We're going to learn about batteries and how to build a simple circuit. But before we do that, let's sing our channel's song. Okay, let's talk about batteries. Have you ever used a battery? Of course you have. Batteries are everywhere. Your cell phone, remote control, flashlight, and so many more things that we use every day are powered by batteries. Batteries store chemical energy, which can be changed into electrical energy. Electrical energy is what powers all of the things that we plug in or use wirelessly. And batteries are what allow us to use electricity without being plugged in. This is because batteries contain the components necessary to create an electrical circuit. They're like little power stations that we can take with us wherever we go. Here we have a battery. Inside this battery is a mixture of chemicals that store energy. At the bottom of the battery, there's a metal plate called a cathode, and at the top is another metal plate called an anode. Between these two plates is an electrolyte, which is a substance that allows electricity to pass through it. Now, when you connect a circuit to this battery, you complete a path between the anode and the cathode. Because of the special chemicals inside the battery, electrons are able to flow from the cathode through your circuit and back to the anode. This flow of electrons is what we call electric current. So remember, batteries convert chemical energy into electric current. Electric current is measured in amps. Most batteries have a voltage of around 1.5 volts, but batteries come in all different shapes and sizes with different voltages. For example, car batteries are much larger than the batteries that you might find in a toy or handheld device. Now that we know about batteries, let's learn about circuits. A circuit is a complete path that electricity can follow to get from the positive side of the battery to the negative side of the battery. Electricity always wants to flow from the positive side to the negative side. If there's a break anywhere in the circuit, then the electricity cannot flow and nothing will work. Circuits must be closed in order for electricity to flow through them. This means that the circuit must be a complete loop. Think of it like a water balloon. If you poke a hole in the water balloon, the water will leak out and deflate. Likewise, if there's a break in the circuit, then the electrical circuit is open and the flow of electricity stops. But if the circuit is unbroken, then the electrical circuit is closed and electricity will flow through it. You know, everything that uses electricity needs a circuit. All circuits are made up of 5 main components. The first component is a power source, which is usually a battery. The second component is a conductor, which is a material that electricity can flow through easily, such as a wire. The third component is a load, which is anything that uses up the electrical energy. For example, a light bulb is a load. The fourth component is a switch, which is used to turn the circuit on or off. And the fifth component is a fuse, which is a safety device that protects the circuit from too much current. There are 2 types of circuits. They're series circuits and parallel circuits. A series circuit is when all of the components are connected one after the other in a single loop. An example of a series circuit is your Christmas lights. If one of the bulbs burns out, then the entire string of lights will stop working. A parallel circuit is when the components are connected across the same 2 points. In other words, there are multiple paths that the electricity can travel along. An example of a parallel circuit is your home's electrical wiring. If one of the lights goes out, then the rest of the lights will continue to work. Circuits can be used to power all sorts of things, like motors, buzzers, lights, and switches. Today we are going to learn how to make a simple circuit with a battery and a light bulb. Get a 1.5 volt battery, 2 pieces of wire, and a light bulb. Connect one end of the wire to the positive side of the battery and connect the other end of the wire to the light bulb. Do the same thing on the other side. Connect the remaining wire to the negative side of the battery. If you've done it right, you should see the light bulb light up. Congratulations! You just made a simple circuit. Let's do another demo. Here we have a battery connected to a light switch and then to a light bulb. When the switch is closed, the circuit is closed and the light bulb lights up. But if we open the switch, the circuit is open and the light bulb goes off. That's how a light switch works in your house. And now we're going to do a fun challenge. Try connecting 2 light bulbs in series to a battery. Can you get both of them to light up? Remember, the electricity has to flow from the positive side of the battery to the negative side. So connect the first light bulb to the positive side of the battery, and connect the negative side of the first light bulb to the positive side of the second light bulb. Then connect the negative side of the second light bulb to the negative side of the battery. Once you've completed the circuit, you should see both light bulbs light up. That's all for today, folks. I hope you had fun learning about batteries and how to make a simple circuit. I can't wait to see what you invent next. In the next episode, we'll learn about resistors, capacitors, and switches. Stay tuned. If you liked this video, hit the like button and subscribe to the channel. You can also watch these related videos. Thanks for watching and I'll see you next time. Bye.